What is up, Math Mob? We are back at it again. Today, our topic is recognizing different types of slopes. And our focus question: how can you tell if a slope is positive, negative, or has no slope? So, go ahead and take a look at the warm up and see if you can figure out which line does not belong. Okay, so let's take a look at each line here. Some of you may have said line T. Obviously, it's line T because that's the blue one, right? That's the blue line. Some of you may have said, no, it's not line T. It is line U. Obviously, it's line U because line U has a slope of 2/3. And all these other slopes have a slope of 1/3. Here's a rise of 1, a run of 3. The blue one has a rise of 1, run of 3. And V, we're actually going down 1 here and over 3. So obviously it's line U, right? Because it has a different slope than the other ones. But some of you may have said, wait a minute, I think it is line V because it's the only one that's going down. As you look at these from left to right, V is going down. All these others are going up. So all valid points, just depending on your perspective, right? Which one is different? Okay. If you've ever ridden public transportation, sometimes you may have bought a card that you can use. You put money on it, and then every time you use a bus or the light rail or train, trolley, wherever you're at, you swipe your card and money comes off your account. Your preloaded card, however much money you put on there. So we have a situation like that today. Noah put $40 on his fare card, and every time he rides public transportation, $2.50 is subtracted from the amount available on his card. So how much money in dollars is available on his card after he takes 0 rides, 1 ride, 2 ride, or X rides? And I'm going to add another one on there. Before you get to D, we'll call it C and a half, right? C and a half, C.5. What if he takes 10 rides? So go ahead and do A, B, C, C and a half, and then D. Okay, so if he takes 0 rides, that means he starts out with $40 and he doesn't use it because he takes 0 rides, so he still has $40 on his account. If he takes 1 ride, I'm going to take that $40 and subtract $2.50, so that would give me $37.50. And then 2 rides, I know that's one more than 1 ride, right? 2 rides is one more than 1 ride. So I could just take away another $2.50 here and up with $35 for 2 rides. Now what about 10 rides? I know that I could just keep subtracting 2 rides and then 3 rides and 4 rides and 5 rides, but I know that each ride costs $2.50, so I'm going to take this 10 rides, multiply it by $2.50, and that is $25. So that's how much is taken off of his $40 card. So 40 minus that 25 leaves me with $15. So that might help me get this X rides, right? So if he goes X rides, I know however many rides he takes, is going to be 250, $2.50 times X, but that'll tell me how much is taken off of his card. So I have to take $40 and take away that $2.50 times X. So I'm going to rewrite that a little bit. I'm just going to rewrite that, and I'm going to say 40 minus 2.5x, because 2.5 can represent $2.50. So if he takes 10 rides, 2.5 times 10 is 25. 40 minus 25 is 15. Or if I have 0 rides, right? 2.5 times 0, 40 minus 0 gives us 40. So it matches up with what we have up here. Part number 2 says graph the relationship between the amount of money on the card and number of rides. So I'm just going to take these points and I'm going to graph them. So at 0 rides, he is at $40. 1 ride, he's at $37.50. Where is that? That's somewhere in here. I'm just going to go down to 2 rides and go to 35. 2 rides at 35. I know 10 rides is at 15. 10 rides is at $15. And then how many rides can Noah take before the car runs out, or before the card runs out of money? If I follow this down here, well, let me draw a line there. I'm going to draw a line through those points, just like that. And I can see it ends up at $16. Now here's the thing. If I draw a line through those points, that means there is data in between these 2 points. There's data here, 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 and here. So between 0 and 1, say 1/2, right? If I go 1/2 right here, and I go up, it's going to cost this much. But here's the problem. Can he take half of a ride? When you use public transportation, you have to pay the full amount, no matter how far you're going, even if you're going to the next stop. So whether you go to the last stop or the first stop, you still have to pay for 1 full ride. You're still going to have to pay that amount. So I am going to take away that line because there shouldn't be any data in between those points. And I know we've drawn a lot of lines with linear equations so far, but here's an example where a line really isn't appropriate even though it is a linear relationship. Another example may be if there's a bike rental place and to rent one bike it costs $10. So you rent 2 bikes, it costs $20. 3 bikes is $30, right? So that's a linear relationship. Every time you rent a bike, it goes up by $10. But you can't rent half a bike, right? You can't rent half a bike for $5. Unless it's a unicycle. No, that wouldn't work. You can't rent half a bike for $5. They only have 2-wheel bicycles. So well, that's the definition of a bicycle, right? Bi is 2, so 2 wheels. Anyway, so $40 for 0 rides, $37.50. Every time he takes a ride, it goes down by $2.50. So we keep going down by $2.50, and we end up at 16 rides. Now he has $0 on his card. So we made the graph, and we don't draw a line through it because you can't take half or 1.5 rides or 3 1/4 rides. So we made the graph, and how many rides can Noah take before the card runs out of money? 16 rides. Oops. 16 rides, and we see that when our our y coordinate value is 0, right? Our y-axis value is 0, which is dollars on card. Okay, so on this graph, why do you think it might make sense to say that the slope of this graph is negative 2.5 rather than 2.5? So some students said, because it's going down. The graph is going down, so it's negative. Another person referred back to the expression for dollars on a card, and the dollars on the card on the y-axis is equal to 40, the original amount on the card, minus 2.5 times however many rides you take. So they said, since we are subtracting money from the card, then it makes sense that the slope is negative 2.5. And we had another student say that if you made a table of rides and amount of money on the card, if we made a table of those values, we start off with $40 in our account, and then every ride that's taken, even if we have multiple rides, it's the value of the amount of money is going down. So that's another reason why this might be negative instead of 2.5. If it was positive 2.5 or positive $2.50, he'd be adding money onto his card, right? But he's taking away money from his card. He's taking away $2.50 every time he takes a ride. And it makes a graph that's going down. Every time the x value goes up, the y value is going down. Okay, so here are some lines from the warm-up. We had this line V, and line T. Line T was the blue one. We said one might have been different. So let's take a look at line T. Line T, if we pick a point, we pick 2 points, right? And we can make a slope triangle. And we start at this point, and we're going over one and up one. If we start at this one, we go up one and over one. But either way, we have a slope triangle. We're going to the right one, we're going to the right 3. Our horizontal distance is 3, vertical distance, and then we go up. If we look at this point here, and we do the same thing, we're just going to go straight over to this point. We're going up 1, but we aren't going to the right? We're going to the left so this would be -3. So in this case, our slope would be 1/3. And in this case, our slope would be vertical distance over horizontal distance, 1/-3. I know you might be saying, but wait a minute, Mr. Anderson, what if we go this way? What if we start at this point? Okay, we can do that. We can start at this point and go to the right Now we're going towards the positive numbers, right? If these are numbers down here. This way is going towards the positive. They're getting bigger. So that's 3. But then we go down. We aren't going up. We're going down to -1. So we have, here's where what our two slope triangles said. We said negative, or 1 over -3. Or now we got -1 over +3. So either one of those is going to be negative, right? It's going to be negative. 1 divided by -3 is -1/3. -1 divided by 3 is -1/3. What about this? What if I started this one? Then I'm going down. So that's negative. If I start at this point, I'm going down. So that's negative. You're right. It is negative. So let's see what happens. If we start at this point, we go down 1. We get -1. And then we go to the left. So we're going from positive numbers towards negative numbers, where the numbers are getting smaller. So that would be -3. So -1 divided by -3 is +1/3, right? A negative divided by a negative is a positive. So we can see the slope is going up, it's positive. This slope is going down, so it's negative. Let's look at another graph. So this graph is showing Hans Fair for the month of July. What do you notice about this graph? What do you wonder about this graph? Some of you said that, well, Han doesn't use his card at all. He doesn't use his card because the dollars on the card stayed the same no matter what day it was. And you noticed that it made a straight line. So some of you wondered, is he okay? Is something wrong with Han? Why didn't he use his fare card that month? How can we find the slope of this line? We could do, remember, slope is vertical change over horizontal change. Or rise over run. So if we pick 2 points, say we pick this point and this point, our vertical change, I don't go up, do I? I don't go up, I don't go down, I just stay right there. Vertical change, it doesn't change actually. It stays at 0. So I could put that. I could take vertical change of 0, and my horizontal change would be 1, 2, 3, 4. Vertical change over horizontal change, 0 divided by 4 is equal to 0. Well, let's do another one. Let's try another slope triangle with a vertical change of 0, which is kind of weird because the triangle needs a vertical change, right? But in this case, mathematically, we're going to say the vertical change is 0. So we aren't really making a triangle because it doesn't go up or down. But I'm going to do this point and say this point right here. Just picked a random point. So I have a vertical change of 0 and a horizontal change of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 0 divided by 10 is 0. So here I have a slope of 0 also. No matter what 2 points I pick on this line, I'm always going to have a slope of 0. And that's what a vertical line has, a 0 slope. It doesn't go up, it doesn't go down, it stays the same. And we're going to talk about vertical lines in a minute. Horizontal, did I say vertical or horizontal? Horizontal lines always have a slope of 0. It doesn't go up or doesn't go down. So what happened with this fare in July? It didn't change. It stayed at $20. This point right here is $7.20. I'm just picking random points because it says plot and label 3 different points. 17 and 20. And I'll pick this one right here. 30 and 20. I'm going to do one more right here because I think that's important. 0 and 20. Write an equation that represents the amount on the card in July after X days. So if I made a table, I'm going to make a little table here. I'm going to say 0 days, 1 day, 2 days, 3 days. And days are my X. And dollars on the card is my Y. So here are my two variables, days and amount on card. So after 0 days, I got 20. After 1 day, I got 20. After 2 days, 20. 3 days, 20. 19 days, 20. No matter what. No matter what day it is. It doesn't matter. Any of these days, the Y is equal to 20, right? So we could say that, we could just say that Y is equal to, we could say it does have a slope of 0, so we could say 0 times X is, whoops, not plus, 0 times X, because he doesn't use the card, plus 20. Or, really, any number times X is 0, right? So we could just say Y is always equal to 20. Y is equal to 20. That's it. All right. So here is another situation. Elena borrowed some money from her brother. She pays him back by giving the same amount every week. The graph shows how much she owes after each week. So go ahead and answer these questions on your own, and then we'll talk about them. Okay, number 1, what is the slope of this line? So I'm going to pick 2 points. I'm going to pick this point right here, 15, and this point right here, number 2. Or 15, and this point right here looks like it is 10, 11, 12. So if I make my slope triangle, I am going to go up from 12 to 15. I'm going up 3, but then I'm going to go left -1. So my rise is 3, my run is -1. 3 divided by -1 is equal to -3. So there's my slope, -3. And if I could redo this. I could just say I'm going up 3 and over 1, and I know it's negative because my line is going down. As my weeks get bigger, my line is going down. So I could say that this slope is -3. Okay, there's my slope. And I know it's negative because the line's going down. What does a slope represent in this situation? So -3, what does that represent? -3 means she's paying her brother back. So every week she owes him $3 less than the previous week. So the amount she owes is going down by $3 every week. That must mean she is paying him $3, right? She's not gaining $3, or the slope would be going up. She's losing $3. Not really losing. She's paying back $3. How much did Elena borrow? Well, if we look at the beginning point, this is 1. So this would be 0, right? On our y-axis is 0. So she started off owing this amount right here, which looks like $15, $16, $17, $18. And how long will it take her to pay all the money back that she borrowed? Well, if I look down here at when she owes $0, right, amount owed. If I look at $0 when she doesn't owe anymore and go over here, it looks like, whoops, this must be, there we go, 6 weeks it's going to take her to pay all the money back. And that makes sense because 6 times -3 is -18. Our starting value was $18 owed. If she pays him $18, 3 times 6 is 18. So it's going to be 6 weeks. Okay, let's take some notes. What does a graph with negative slope look like? It goes down. It looks like this. It goes down as the x value increases. The line's going down. What about a graph with a slope of 0? Graph with a slope of 0 that looks like a straight line, right? It just looks like a straight line going across. And we can say as the x value increases or decreases, really. As the x value increases, the y value stays the same. It is constant. It stays the same. What does the equation of a negative slope look like? Well, it looks almost like the equation of a positive slope, except that there is a little negative sign in front of our rate of change. Right? Our rate is negative, so that means our slope is going down. It means the value is going down every time the x value increases. The y value is going down, so we say it's negative. This indicates a negative slope. So our example today was a negative slope, negative 2.5, negative $2.50 every time he uses his card, and he started with $40. So here is the difference. This little negative sign is the difference between a positive slope equation and a negative slope equation. This is a negative slope. And when would you not draw a line on a graph to connect points? When there cannot be data between the points. For example, you cannot take 1.5 rides on the light rail.